We can also use differentiation to find a point that is closest to another point on a line. Here in example 3, find the point on the graph of y equals 2x squared. So we know how to draw y equals 2x squared. That is closest to the point 4 and 1. So here for y equals 2x squared, we're going to see points that has coordinate 1 and 2, and then when x equals 2 we have 8. So we're going to see a parabola that opens this way, and same thing on the other side. And you're trying to find a point somewhere on this parabola that is closest to the point 4 and 1. So here, if this is 4 and 1, I would assume the point on this line to be on the line that is perpendicular to this curve. But we don't need to set it up using like perpendicular slope, finding the tangent line at this point and things like that. All we need to do is to set up a distance formula. Using distance formula, we can then differentiate this function here, set it to 0, and solve for the unknown. We got a point 4 and 1. And there is a point that we don't quite know at this time. We have x coordinate and y coordinate for this point. For the y coordinate, knowing how the relationship between the x and y is y equals 2x squared, I can consider the y coordinate of any point on this line to be obtained using 2 times x squared. And that means I can now set up my distance formula to be x minus 4 squared plus 2x squared minus 1 squared. And now I can differentiate the left hand side and the right hand side at the same time. But the right hand side at this time looks pretty complicated. We're going to use chain rule to deal with the square root and the things inside. Now there is a better way to deal with this. When it comes to derivative, the slope, the maximum slope that happens for this will give us the same value as if you differentiate the expressions here. So you don't have to deal with the square root. If you can differentiate this one using the expression here, you will end up with the same critical points at the end. So in this case, I'm going to just differentiate this part. Starting with d squared, I want to differentiate it. And on the right hand side, as I differentiate this, I have 2 times x minus 4 plus 2 times this. And don't forget your chain rule. Once you simplify the expressions here, we can then find the critical point. So set it to 0 and solve for x. Now, of course, this is a polynomial. This is a cubic polynomial. And in this case, unless you are to try it with the rational root theorem or using long division, otherwise you probably will have a very hard time solving for x in this case. But in this case, you're going to just use a graphing calculator to solve for the root. So you can get your graphing calculator to draw this cubic polynomial. Find the zeros using your calculator, and you will end up with this value for x. Once you have the x value, you can then put it back to the original function, and that will give us the y coordinate as well. And this is the coordinates for the point that is closest to 4 and 1. So altogether, we have 0.9495 and 1.8031. Now keep in mind that on the IB exam, they want you to have your answer rounded to 3 significant figures. Don't round it to 2 decimal places. On IB exam, they want us to keep everything to at least 3 suffix. You can have more, but you cannot have less.